Yeah, today's concept is about the next concept of your AI, the unit 2, that is resolution and refutation method. So we will discuss about this concept. Yeah. So in previous session, we have discussed about how to apply the semantic rules, semantic tableau method, the rules, and finally get to some uh, truth tree construction using your semantic tableau method. And in today's concept, we will try to enter into something new, a new concept of your uh, discrete structures or your application of discrete structures with respect to your artificial intelligence, and we will try to understand how to apply the previously learned concept in with respect to your problem solving. So the theme is not is same here, like you will be given some set of premises, and finally you need to get some conclusion, and also a valid proof should be provided to that. So according to that, we will be just trying to move on with the next concept called as your resolution and refutation method. And initially we will discuss about what is the resolution, how to discuss about how to get some solution with respect to your resolution for a set of given premises. Okay, so resolution is a theorem proving technique that proceeds by building refutation proofs, that is we call them as proofs by contradiction. So this is also learned by us in the previous years, but the terminology what you are doing learning here is different. So it is called as proof by contradictions, and here we are calling the same with respect to your resolution as refutation proofs. So this concept was invented by a mathematician called as John Allen Robinson in the year 1965. So yeah, so you need to keep these things, these names in your minute things in your mind, because that's how we'll try to keep your concept alive while learning it in the further sessions. Yeah. So when I talk about your resolutions, it is a part of your theorem proving technique or an axiom, whatever we have discussed in the axiomatic systems. It is an extension for the same concept. So you will be given some set of premises, you'll be having some conclusion, you will be trying to prove them according to the given statements. Yeah. So resolution is used if there are various statements given and we need to prove a conclusion of those statements. That's what I said. You'll be having some set of premises given and you need to give valid conclusion or valid solution, and accordingly you need to prove them why the solution is correct or inconsistent or consistent, and accordingly give your statements. Yeah. So with respect to this resolution and refutation method, we'll also learn about something called as unification, which is a key concept while proving your resolutions. Yeah. So resolution is a single inference rule which can efficiently operate on conjunctive normal forms. Yeah. So if you want to understand the concept of your resolution, you need to be aware of this, what is CNF or DNF, what you have learned in the previous sessions. So conjunctive normal form is the key concept of this resolution method. Accordingly we will try to prove your solution problems or give you proofs using your conjunctive normal forms only. Okay. Yeah. So moving ahead with your resolution and refutation method. So resolution is one kind of a proof technique which follows this set of given statements here. So initially, we will be trying to select two clauses that contain conflicting terms. Yeah. So as I said here, you'll be having some set of premises. It can be 4 premises, 5, 6, or many. And from that, you will try to take two premises, or we call it as two clauses here. And we will try to see among the given statements how many terms are conflicting. So if there is a conflicting term, what to do, that's what we need to understand. So we need to combine those two clauses and cancel out the conflicting terms. So conflicting term here indicates the term which is repeating continuously and which that need to be cancelled, and finally we need to get some solution. For example, you can see here the two statements or the two clauses given here. The first clause is saying that if it is a pleasant day, you will do strawberry picking. That is one statement what we are taking. And the second statement or second clause states that if you are doing strawberry picking, you are happy. So here you can see a common thing between these two statements, that is strawberry picking. This is the conflicting term we call according to your resolution. Okay. Yeah. Let's see here how the statements can be written with respect to your propositional logic. Yeah. So the given statements, the previous two statements, statement 1 and statement 2, can be written with respect to your propositional logic in the given manner. Strawberry picking implies your pleasant. That is, pleasant implies your strawberry picking, and strawberry picking implies your happy. So here you can see A implies B and B implies C. That is, A implies C. The same thing we are going to apply here with respect to your propositional logic. So this is how you are writing your given statement. And next, we are trying to convert these statements into your conjunctive normal form. So when I talk about your resolution, you'll be given your two clauses. The two clauses need to be written with respect to your uh, propositional logic. You need to understand what are the conflicting terms. Then try to apply, try to convert them into your conjunctive normal form. That is the theme of your given concept called as resolution and refutation method. You need to try to convert the given clauses into your conjunctive normal form. And finally, you can see here, it is being converted into your implication is converted to your conjunction. So when I say an implication is converted to your conjunction form, it is negation and sorry, it is or and negation. So you can see here strawberry picking, a pleasant implies your strawberry picking is converted as negation of pleasant or strawberry picking. That's how it is being converted. This is what we call it as your conjunctive normal form. Implication converted to your or gate. That is your negation of or. Okay. So finally, by applying your resolving method on these clauses, you need to get some conclusion. So from the given two statements or the given two propositional logical statements, you can see here 1 and 2 are the previously taken things according to your conjunctive normal form, and you can see here 3 is your solution, 3 is your conclusion. According to the statement of your resolution, you need to remove the conflicting terms, you need to cancel the conflicting terms, and finally get to some conclusion. So here strawberry picking is a conflicting term which is being removed, and finally we got the solution that if it is a negation of pleasant or happy, that is your conclusion. This is the concept of your resolution. Whenever you are giving some set of clauses or statements, you need to understand what are the conflicting terms, convert it to conjunctive normal form, and finally get some conclusion. So finally we will have one clause as your solution. Okay, this is how we'll move forward with your resolution concept. Okay, yeah. So summarizing, resolution is a rule of inference. So here again we are talking about your rules of inferences which are leading to a refutation theorem proving technique for sentences in propositional logic. So if you want to understand your refutation theorem in the next concepts, we will discuss about that. You need to understand clearly what is a resolution and how rules of inferences will be similar to your resolution, and finally how we will apply this to your refutation theorem with respect to your propositional logic. Yeah. So applying the resolution rule in a suitable way all allows for telling whether a propositional formula is satisfiable or not. So definitely, whenever you are going to apply this concept of resolution, at the end, as I said, you need to get some solution which should be a satisfiable solution. Accordingly, you need to provide your proofs. That is the concept of your resolution. Okay. So you can see a small glimpse or of what is that you are discussing. So what is the resolution rule here? So here you can see in the box, the first box here you can see negation of alpha implies beta, comma, beta implies gamma. So finally you're getting a conclusion that negation alpha implies your gamma. That is your solution. Okay. So equivalently you can convert it to your conjunctive normal form as alpha or beta, comma, negation or gamma. That is implication is converted to your conjunction form, CNF, that is or form. That is what is called as your resolution rule. So the same statement can be written or converted to your conjunctive normal form. Okay. So applying the resolution rule, That's what we have discussed in the previous example. Here is one more example to understand the concept of your resolution. If I say, if I take a sentence like summer or winter, comma, negation of winter or cold. If I am having these conjunctive normal form sentences, the conclusion need to be like summer or cold, because here winter, comma, negation winter are the conflicting terms. The conflicting terms need to be cancelled, and finally you need to get some one statement called as your conclusion. So using the resolution rule to eliminate the literal form both sentences, finally the conclusion is summer or cold. That's how resolution rule concept is being discussed. So these are the steps what we need to keep in your mind while discussing about your resolution refutation problem. So I want everybody of you to please make a note of these statements, as in the upcoming concepts these steps will be discussed broadly. So you need to, so when you are given some set of premises similar to your rules of inferences, you can apply any of your rule, and finally you need to convert it to your conjunctive normal form, that is in the form of P or Q or Q or R or negation Q or R, any manner. You need to have a separation of R or in between your two premises P or Q. That is what we call it as your conjunctive normal form. So later in the next step, we need to you need to negate the desired conclusion, converted to your CNF. The CNF form what you are converted, that should be negated, and apply resolution rule until either you get a contradiction or you cannot move your further. So up to the last possible solution, you need to apply your resolution rules and finally get to some conclusion. So either you need to prove it wrong, or if you are saying it is a valid one or satisfiable one, you need to give your solutions until you get that. That is the thing we'll discuss about your resolution refutation. Yeah. So basically resolution refutation is complete and it's also sound. So what does this mean? Why you're calling it as complete, or why it is a sum? So it's complete because it always generates an answer. That is the main thing what you need to keep in your mind. So resolution refutation method is always complete because it finally generates an answer. It is also sound. It is also called as sound because the answer is always correct. There is no possibility of saying that answer is wrong. Yeah. So that's how you'll be trying to prove your statements with respect to your uh, conclusions from the given axioms. If we can't apply further using your resolution principles, the conclusion cannot be proved from the given axioms. That's how we'll be trying to learn about your resolution and refutation method. So here is a small example what we'll be learning about your given premises, and finally you'll be trying to get some conclusions. Yeah.